Hey everyone, welcome to the next tutorial series of Polygon, zkEVM testnets, and decentralized applications. So in this video series, I'm going to show you how to create this decentralized application on Polygon. So this application was built by me for animal shelters, where animal shelters can track data of animals that exist inside each and every shelter, like a shared database, right? So they can add their shelter name, their country of the shelter, city, zip code onto the blockchain, and then they can update if the shelter is at capacity or not according to their shelter ID. And all this information will exist on the Polygon network. And then if shelters are interested in finding out information about other shelters, like I want to get information about maybe my shelter, shelter number 1, right? Then I could connect to my wallet, search shelter information. I get shelter number 1. This is my name of my shelter, USA, zip code, blah, 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 blah. Add capacity is deleted. Maybe I want information about shelter number 2 that I know exists next door. So here's name 2, and so on and so on. Now, I also integrated, this is a great learning experience for me and for you. I integrated this function that will pull all shelters that have capacity, right? So let's say I'm in New York City and my shelter is going through there's a big virus, right? A dangerous virus in the shelter, and I need to move animals to a different shelter. Now, instead of making phone calls to other shelters, figuring out who's at capacity, who's not, who can take my animals, I'll go into this database that all shelters are potentially using, and then I'll search all shelters that are at capacity. So false, they're not at capacity, meaning that they could take in more animals, and then I can get their information, and then I can give them a call. I can probably add phone number to the blockchain. So this is the idea of the centralized application, and so I'm going to show you how to do all this, how to insert data onto the blockchain, how to create modifiers, error messages, structs, events, everything you need to know in order to create a pretty decent decentralized application. And this is probably the most exciting part, where you can actually filter shelters according to certain information, in this case at capacity. All right, so we're going to break this down into several different video tutorials, so it's not 3 hours long, one video. In the first video, we'll go over the contract. I'm going to explain the contract to you. All right, in the second video, I'm going to explain how you can create a hardhat project and deploy this to the Polygon zkEVM testnet. In the third video, we're going to create the front end, right? We're going to create a front end project with Next.js, and then we're going to create this whole JavaScript so you can have something similar on your computer. And in the last video, I'll show you how to deploy this to Vercel.com, so your whole repo, your whole project, so you can actually have your own link like I have here that you can share with anybody in the world. All right, so you're going to learn a lot. If you have any questions, feel free to ask under the YouTube comments, or go to the Polygon forum. I'm also active there, and you can see some, and I'll try to answer any questions you have on that forum. All right, oh, don't forget my YouTube channel is something that I like creating videos on to share with you. So if you find this video beneficial, click the like button, become a member or subscriber, and turn on the notification button so you're aware of all the videos I'm going to publish from this tutorial series. All right, so let's get started. Let's go to the link under the video. Is going to be this link right here. I put everything, this whole project, on my GitHub. So go to the animal shelter, this link, and you really just want the contract right now. So go to backend, contract, and the shelter.sol, right? And then you can take all of this and just paste it into Remix. Just go into remix.ethereum.org, create a new contract, a new file, not file here, call it shelterdb.sol and or shelter.sol, it doesn't matter, probably shelter. Actually call it shelter.sol. And then just paste everything in here. Once you have it pasted, let's save it. Now for me it's saved. I make sure that you're in the same version, 8.18 right here or higher. So I saved it, compiled, and now I want to deploy it just on here on like a testnet, so we can interact with it on a Remix. So I'm going to choose Shanghai. This is a fake address. There's like 10 fake addresses. ShelterDB, and then we're going to hit deploy. All right, so we just deployed the contract, and look at all the functions that we have here. The difference between the orange ones and the blue ones is that the orange ones are inserting data onto the blockchain. We're adding a pet, we're adding a shelter, we're updating the shelter capacity on the blockchain, we're updating the shelter status if it's deleted or not. So this is inserting or uploading data, and this is just reading data from the blockchain. All right, so let's do one example. We're going to add a shelter. Click on this, and we'll see shelter name. Let's just say, let's call it shelter 1. Shelter 1. Country, we'll say India. City, we'll say Mumbai. And the zip code, I don't know what zip code they have. 1, 2, 3, 4, 5. Very advanced zip code. Transact, and we'll see that it worked. If you click down here, we got some information, some gas information. Inputted this in all these arguments, input arguments, and this is what came out of the whole function, right? So now we can actually close this function, and we can take a look at one of the functions that we have, which is getShelterListings, right? I'll show you the function here below later. getShelterListings, all you need is a shelter ID. We know our shelter ID is 1. See, shelter ID 1. So we're going to put shelter ID 1, call, and then we get all this information of the shelter, right? First it gives us the data type. Can we make this bigger? Yeah. String, and then it'll tell us the shelter ID 1, India, Mumbai, and so on and so on. All right, so we see that it worked. Now let's look into the contract and see what each one of these buttons, what they are related to, right? What functions and mappings and so on and so on. So first we have the Pragma Solidity version 0.8.18 or higher. We'll call this contract ShelterDB. Make sure you leave it the same name, okay? Because it might affect how you execute your project. We'll create 2 different state variables, total amount of pets and total shelter IDs. And I just created this for myself because I wanted to know how many people, how many shelters are using this contract. 100 shelters, 200 shelters. We'll have 200 IDs, and how many pets, right? Every shelter can have 10 pets, 20 pets. So maybe total we have like 100 shelters and 1,000 pets. So we'll update this inside the functions. And then we have an event, shelter added, and we'll trigger this event, we'll emit this event when we add a shelter, when the user adds a new shelter. All this will also be added to the log data of the Polygon blockchain. Okay, then we have a struct, we have pet and shelter, and this is all the information that we are going to require of the users. Do they want to put a new pet into their shelter? Then they're going to have to give us the pet name, the pet type, age, sex, ID, blah blah. If they want to put a new shelter, their own shelter onto the blockchain, then they have to give us a shelter name, the country, at least these 4. We'll populate this automatically, but they will have to give us this first 4. I also created these mappings, and these mappings are going to help us look up data according to certain input variables, right? So we're going to allow users to enter several different shelters. Hopefully, everybody in every city in the world enters a shelter onto the blockchain. So we need a way to look them up that is gas efficient, and this is one way. We can create this mapping. It's kind of like a dictionary where it will take the shelter ID 1, 2, 100, and then it will return the shelter struct, right? So if there's like 1,000 shelters and I know that my shelter ID is 1001, then I'll return shelter listings, shelter ID 1001, and this will return my own specific shelter. All right, so this is the mapping. Same thing with shelter pets. The only difference, it will return a list of pets. Instead of returning one shelter, like one pet, it will return a list of pet arrays, right? Struct, a list of structs. And then this is like a dictionary within a dictionary, because we are going to check if actually a certain pet ID exists. If a pet ID exists, we don't want the shelter to put the same pet ID. They will have to create a new ID. The error messages are a good way to save gas. So I put them here. They're used inside the modifier, and when we insert the modifiers into certain functions, like let's say right here we have a modifier. When somebody looks for shelter listings, we'll put the only existing shelter, because if they put an ID, a shelter ID that doesn't exist, I want an error to be produced, right, to be triggered. So if somebody put a shelter ID number 2, we'll put it right here. Get shelter listings number 2 does not exist. We only have shelter ID 1. You see this error message, shelter not available, right? And this is because of this modifier that is right here, that is checking if the shelter ID is bigger than all the shelter IDs in the blockchain, or if the shelter ID equals 0, then it's incorrect. It doesn't exist. So it will revert to this error message. So we have 3 more modifiers to check 3 other things. If the shelter owner is the one triggering the function, if the shelter was deleted, or if a pet ID already exists or not. And then we have our first function, addShelter. So we're just taking 4 different input variables, and they're all of string memory type: name, country, city, zip code. And when they trigger the function, when they activate it, total shelter ID will do +1. So we already entered a shelter ID. Remember, we entered this shelter, but now when we add a shelter, let's add shelter number 2. When I click transact, this will become shelter ID 2. So this new struct, this new shelter struct with all this information will be in the mapping. It will go into shelter ID number 2, right? Shelter listings 2. So go back to the mapping again. Shelter listings 2 will create this new struct, right? And now we're going to insert information into the struct. I'm asking only this information in the function. You see right here, only this from name to zip code. But these 3 I'm going to populate automatically. Let's go into here. See, right here. I'm going to take the input underscore shelter name, shelter country, and assign it to the struct variables, to the respective struct variables. But this I'm going to input automatically. At capacity, I'm going to say false. If you're just entering this shelter into the blockchain, then you're probably not at capacity. You can take in more animals. So initially this is false. The shelter owner is the message sender. When the user triggers this function, they will have to trigger it with their wallet, MetaMask, Coinbase, and it will read who the sender is, right? Who the wallet signer is. And this will be equal to the shelter owner. It's an address. And deleted false because this shelter has not been deleted. It's a new shelter. Is deleted is an interesting variable here, because you cannot delete information from the blockchain. The blockchain is immutable. Information in there is supposed to last forever. So you can't really delete shelters. But what happens if a shelter burns down, unfortunately, or closes down, or loses funding and no longer exists? Instead of deleting the shelter, we'll say, we'll add a variable that takes the boolean of false or true. So if the shelter is no longer active, we'll just put is deleted true. And then when we pull the shelters, we'll only pull shelters that are not deleted, that deleted is false. And then we, at the same time, we emit this this event, right? Shelter added event. Remember from the very top, shelter added event, which is pretty much the same information that we have inside the struct. I was playing around with this. I think the way I'm building out the project, the front end, you don't really need this. You only need the shelter ID. We're not going to use anything else in the events. But for now, let's keep it this way in case you find different usage for it. All right. So we have our addShelter function, and then we have another function to get shelter listings. Now this get shelter listing is blue because we're pulling data from the database, we're returning data, and we're not adding data to the blockchain, right? So this is, we're only going to take the input value will only be a shelter ID. It will be a uint, and we can see here get shelter listings. This is it, and it'll take the shelter ID. Let's take number 1. And then is this a public function? It's view, again, because we're only reading data. We're not inserting data into the blockchain. We're using these two modifiers, only existing shelters and only not deleted shelters, right? Because if the shelter deleted, we don't want the user to see these shelters. And then it's going to return a shelter struct of memory type, right? So this is returning right here the mapping of shelter listing, shelter ID. So it's going to take the shelter ID and try to go into the value of this key, right? Shelter listings. So let's go to shelter listings. You'll see here shelter listings ID would be 1, the shelter ID, and then it will spit out the shelter struct, right? The shelter struct. So there we go. We're returning a shelter struct. Let's test this out. Get shelter listings 1. Well, let's do 0 shelter listing. This doesn't work. It throws an error because 0 is not possible. But if we return 1, then it works where you get this. And if we return, let's put this new shelter ID 2. We'll say France, and we'll say Blois. Let's put them in Blois, in the city of Blois in France, and zip code would be 09872, whatever. Transact. Okay, now we can get shelter listing 2, and we'll see that we have France, Blois, and all this information. All right. Then we have 2 more things. We have update shelter capacity, right? And update shelter capacity allows the shelter user to put in their shelter ID and a new capacity. And I'm only doing it for only the shelter owner can do this, a shelter that's not deleted, and an existing shelter. These are my modifiers, right? So if let's say the owner, if I change, let's go to update shelter capacity. Update shelter capacity, where is that? Right here. Shelter capacity. We'll say my shelter ID is 1. And Boolean. It started with false. Capacity was at false. So let's put capacity true. Transact. Done. And now if we get shelter listing 1, you'll see the capacity right here is true now, right? It's no longer false. But this is because I am up to shelter capacity. I am the shelter. This shelter exists, right? So it worked. If I put shelter ID 15, you got an error. Shelter not available. If I put shelter ID 1, my shelter ID, but I put the shelter owner is not me. Let's change address here. Let's be someone else. And I put this shelter owner, shelter capacity 1, but I'm not the owner. I transact it with my wallet. It'll say, nope, you're not the owner. You can't do this, right? So it has to be the owner of the creator of the shelter. And that's it. Now I'll change it back to false. False. Transact, and it worked. Go back to 1, and we'll see now it's false. Perfect. We can do the same thing with update shelter status to update it to if it's deleted, false or true. And then we can add a pet. Add a pet is very similar to addShelter, very, very similar function. The only difference is that we are creating this mapping, and we're making this pet ID, this new pet that they're adding, we're making it true. So if they try to add another pet next time, it will read this modifier, and if the pet ID is the same that they used before, it will say no, it'll give an error, this pet is already taken. So they have to put a pet ID that they don't have in the shelter. It will turn the pet ID to true, and then it will put all the information into the pet struct. And that's it. And then we get shelter pets of all the pets that we have inside the shelter. All right. I know there's a lot of information here, so you might have questions. Definitely feel free to post the questions under the YouTube video or on the Polygon forum, and I'll try my best to answer them. I hope you learned a lot. If you did, click the like button, subscribe to my channel, and don't forget, we're better together, so always help each other out.